Chapter 3-1 Amplitude Modulation Concept. So before we start, I prepare a short video clip that discuss about what amplitude modulation is.
What is amplitude modulation? AM. When the amplitude of high-frequency carrier wave is changed in accordance with the intensity of the signal, the process is called the amplitude modulation. In the amplitude modulation, only the amplitude of the carrier wave is changed. The frequency and the phase of the carrier wave remains constant. The first visual shows the principle of amplitude modulation. The diagram also shows the audio-electrical signal of frequency Fs. The second visual shows a carrier wave of constant amplitude with frequency Fc. The third visual is the amplitude modulated wave. It is to be noted that the amplitudes of both positive and negative half cycles of the carrier wave are changed in accordance with the signal. Thus, the amplitude of the modulated wave possesses the frequency of the audio signal waves.
So, as the name suggests, in AM, the information signal varies the amplitude of the carrier sine wave. The instantaneous value of the carrier amplitude changes in accordance with the amplitude and frequency variations of the modulating signal. Figure 3-1 shows a single frequency sine wave intelligent signal modulating a higher frequency carrier. The carrier frequency remains constant during the modulation process, but its amplitude varies in accordance with the modulating signal. An increase in the amplitude of the modulating signal causes the amplitude of the carrier to increase. Both the positive and the negative peaks of the carrier wave vary with the modulating signal. An increase or a decrease in the amplitude of the modulating signal causes a corresponding increase or decrease in both the positive and the negative peaks of the carrier amplitude. An imaginary line connecting the positive peaks and negative peaks of the carrier waveform gives the exact shape of the modulating information signal. This imaginary line on the carrier waveform is known as the envelope. So, why are sine waves important? The sine wave is important in physics because it retains its wave shape when added to another sine wave of the same frequency and arbitrary phase and magnitude. It is the only periodic waveform that has this property. Another question is, why is FM better than AM? In AM, a radio wave known as the carrier or carrier wave is modulated in amplitude by the signal that is to be transmitted. FM is less prone to interference than AM. However, FM signals are impacted by physical barriers. FM has better sound quality due to higher bandwidth. So, why sine wave is used as carrier? In modulation, we modulate the message signal with carrier frequency of any particular frequency. So, it will always be sinusoidal. But since carrier signal is waves, it's just needed for transmission over long distance and carrier no information, because all the information is carried with message signal. So, how does a carrier wave work? A carrier wave is a pure wave of constant frequency, a bit like a sine wave. To include speech information or data information, another wave needs to be imposed called an input signal on top of the carrier wave. This process of imposing an input signal onto a carrier wave is called modulation. So, figure 3-1, amplitude modulation, which the letter A, the modulating or information signal, the letter B is the modulated carrier.
Frequency of an RF channel is best understood as the frequency of a carrier wave. Now, what is a carrier wave? It's a pure wave of constant frequency, a bit like a sine wave. By itself, it doesn't carry much information of a kind that we can relate to, such as speech or data. To include speech information or data information, we need to impose another wave on top of the carrier, an input signal. This process of imposing an input signal onto a carrier wave is called modulation. In other words, modulation can be thought of as changing the shape of the carrier wave to somehow encode the information that we're interested in carrying, speech or data information. It's like hiding a code inside the carrier wave. Recall that any wave has three basic properties: amplitude, which is the height of the wave; frequency, which is the number of waves passing through in a given second; and phase, which is where the phase is at any given moment. We can tweak the height of the carrier. If we create an input signal whose height varies with the loudness of our voice, and we add this to the carrier, then the carrier's amplitude will change corresponding to the input signal that's being fed into it. This is called amplitude modulation, or AM. Suppose that we change the frequency of an input signal. If we add this input signal to the pure carrier wave, we thereby change the frequency of the carrier wave. In that way, we can use changes in frequency to carry our speech information. This is called frequency modulation, or FM. We could even combine these two strategies to create a third scheme of some kind. Any strategy which combines in some systematic fashion an input signal with a carrier wave to encode speech or other useful information is called a modulation scheme. Modulation schemes can be analog or digital. An analog modulation scheme is an input wave that varies continuously, like a sine wave. A digital modulation scheme is a little more complicated. Voice is sampled at some rate and then compressed and turned into a bit stream, a stream of zeros and ones. And this in turn is created into a particular type of wave, which is then superimposed on the carrier. Why have carriers and modulation at all? Why don't we use that input signal directly? It, after all, is carrying all the information that we're interested in, not the carrier. And it only occupies a few kilohertz in bandwidth, so why don't we use it directly? Why are carriers and modulation needed at all? Well, the answer's got a few different factors to it. First of all, that kind of information could be carried by very, very low frequency electromagnetic waves. There's a problem with this. In order to transmit those very low frequencies, you're going to need quite a bit of amplification in order to boost the power, because they themselves don't have much power. And you're going to need some fairly large antenna in order to transmit all of this. So in order to make it cheap and convenient and use as low power to carry as much information as possible, we use this carrier system with modulated carriers. That, in a nutshell, is the answer.
So, this video discusses how modulation works. Using trigonometric functions, we can express the sine wave carrier with a simple expression: V sub c equals big V c sine 2 pi f sub c t. In this expression, Vc represents the instantaneous value of the carrier sine wave voltage at some specific time in the cycle. So Vc represents the peak value of the constant unmodulated carrier sine wave as measured between 0 and the maximum amplitude of either the positive going or the negative going alternations. Figure 3-1. Fc is the frequency of the carrier sine wave and t is a particular point in time during the carrier cycle. A sine wave modulating signal can be expressed with a similar formula. Vm equals Vm sine 2 pi fmt, where Vm instantaneous value of information signal, the big Vm peak amplitude of information signal, and Fm frequency of modulating signal. So, because complex waveforms such as that shown in figure 3-1 are difficult to draw, they are often simplified by representing the high-frequency carrier wave as many equally spaced vertical lines whose amplitudes vary in accordance with a modulating signal as in figure 3-2. This method of representation is used throughout this book. The signals illustrated in figures 3-1 and 3-2 show the variation of the carrier amplitude with respect to time and are said to be in the time domain. Time domain signals voltage or current variations that occur over time are displayed on the screen of an oscilloscope. So, what is the time domain signals voltage or current variation? So, time domain refers to the analysis of mathematical functions, physical signals, or time series of economic or environmental data with respect to time. And the oscilloscope is a tool commonly used to visualize real-world signals in the time domain. So, ito yung itsura ng oscilloscope. Yan siya. Figure 3-2. A simplified method of representing an AM high-frequency sine wave. The orange line is the modulating signal envelope, and the green is equally spaced vertical lines represent constant frequency carrier sine wave. So, high-frequency carrier waves are needed for effective transmission of information signals because they have the capability of converting wideband signals to low-band signals, transmit many audio signals at a time from the same antenna without mixing them up. Values for the carrier signal and the modulating signal can be used in a formula to express the complete modulated wave. First, keep in mind that the peak value of the carrier is the reference point for the modulating signal. The value of the modulating signal is added to or subtracted from the peak value of the carrier. The instantaneous value of either the top or the bottom voltage envelope V1 can be computed by using the equation. So, V1 is equals to Vc plus Vm equals Vc plus Vm sine 2 pi fmt, which expresses the fact that the instantaneous value of the modulating signal algebraically adds to the peak value of the carrier. Thus, we can write the instantaneous value of the complete modulated wave V2 by substituting V1 for the peak value of carrier voltage Vc as follows. V2 equals V1 sine 2 pi fct. Now, substituting the previously derived expression for V1 and expanding, we get the following. So, V2 equals, open parenthesis, Vc plus Vm sine 2 pi fmt, close parenthesis, sine 2 pi fct is equal to VC sine 2 pi FCT plus open parenthesis Vn sine 2 pi FMT close parenthesis, then open sine 2 pi FCT close parenthesis. Where V2 is the instantaneous value of the AM wave or VAM, VC sine 2 pi FCT is the carrier waveform, and Vm sine 2 pi FMT times sine 2 pi FCT is the carrier waveform multiplied by the modulating signal waveform. It is the second part of the expression that is characteristic of AM. A circuit must be able to produce mathematical multiplication of the carrier and modulating signals in order for AM to occur. The AM wave is the product of the carrier and modulating signals. So, figure 3-3. Amplitude modulator showing up input and output signals. So, VM, the information or modulating signal. The center is the modulator, then output, carrier signal. So, inputs are the signals or data received by the system, and outputs are the signals or data sent from it. The term can also be used as part of an action. To perform I over O is to perform an input or output operation. So, the circuit used for producing AM is called a modulator. Its two inputs, the carrier and the modulating signal, and the resulting outputs are shown in figure 3-3. Amplitude modulators compute the product of the carrier and modulating signals. Circuits that compute the product of two analog signals are also known as analog multipliers, mixers, converters, product detectors, and phase detectors. A circuit that changes a low-frequency baseband or intelligent signal to a higher frequency signal is usually called a modulator. So, a circuit used to recover the original intelligent signal from an AM wave is known as a detector or demodulator. Mixing and detection applications are discussed in detail in later chapters. So, another question is, what is the need of modulating a signal? So, modulation allows us to send a signal over a bandpass frequency range. If every signal gets its own frequency range, then we can transmit multiple signals simultaneously over a single channel, all using different frequency ranges. Another reason to modulate a signal is to allow the use of a smaller antenna. Then, why is AM radio so bad? This isn't the reason why AM sounds bad and FM sounds good. With AM radio, they are allowed to carry by FCC regulations about 11 kHz on each side of the AM carrier, so audio is decent. Your car radio has narrow filters in it, so you maybe only get about 5 to 6 kHz audio bandwidth, making it sound muddy and low quality. Then, what is a modulator? So, a modulator embeds an input signal in a carrier signal using different technologies. AM or amplitude modulation uses a mixer, the IC, transistor, or vacuum tube in the early radio days to multiply both signals and vary the carrier amplitude as per the input signal. And the demodulator is an electronic device which helps in extracting a signal of lower frequency from a modulated signal, which is a combination of modulating signal and carrier wave. But in strict electronic terms, they aren't different. A type of detector called as the envelope detector is used as a demodulator. So, i-discuss pa yan ng ibang chapters. So, That's all. Thank you.